Great. Thank you, Catherine. So as Catherine mentioned, we've been working over the last few months on this innovation challenge for Fuse, and we're excited that we're able to present it now, even though it's virtually. And we titled it The Mosaic Portrait of a Persona, mostly because with the opioid crisis, really in order to get a full picture of it, you do have to piece together multiple sources of data, thus making the mosaic. And for this particular challenge, the thing that we found most interesting was actually trying to identify the person or the group of people that was of interest here, which are pregnant women, postpartum women, reproductive age women. And so we really focused a lot of our effort on how do you identify that persona. So I'll take us through the first few parts of this presentation, and then I'll pass it over to Allie and Sarah and Jesse to finish it out. And we go through our approach, the initial results. We'll show some of the future steps we'd take if we had more time to do so, and then what the value add is. And then we'll open up, obviously, for questions. So as Catherine mentioned, the four of us that will be presenting today, there is a bigger team behind this presentation, however. And so I did want to take some time to give them credit for all the work that they did. Jesse, as we talked about, Sarah, Seema Habash, Ali, Assad, Mahmoud, Catherine Maddow, Gino, and Sarah Rogers, as well as myself, all had a major effort in putting this together. All right, so our approach to this was, so the challenge here was to mine social media data, again, to see if you could correlate the pregnant women, postpartum women, reproductive age women with opioid usage, initiation, relapse, treatment, and other factors therein. The challenges there, though, are it's hard to find that conversation happening on social media, especially the big platforms, the Facebooks, the Twitters. You don't often find people posting about their opioid use, especially if they're pregnant with their opioid use. So we took a step back and had to ask ourselves, how do we piece this person together, and how do we relate that to the opioid crisis that's going on? And our initial approach was to look at more niche communities, forums, online communities in which people would talk more openly about this. And we'll dive deeper into our approach, but we were able to extract that information, expand upon it. So we've started out with a pool of key terms that we were searching for to find these individuals, expand upon it, gather the data. We were able to remove irrelevant pieces of information, annotate it using some advanced tools, classify it, and then eventually evaluate it in the end. And we used a handful of AI tools to do this. And I think what we found was actually quite interesting, and I think you all will like it as well. And I'll let Allie go deeper into our approach.
Okay, thanks, Jack. Okay, so as Jack discussed, the first step in our approach is to extract the right data. And it's quite challenging for us to determine the target population and relative hosts from this target population. So we decided to use Reddit as our data source. It's because Reddit is organized as independent subcommunities called subreddits. And each subreddit centers around a main topic, including opioid and pregnancy and babies, which we're interested in here. And, we can, based on the users' posting histories in these subreddits, to determine they are likely to be our target population. So we use a few different approaches to identify this population and extract their relevant posts. So 3 segments here. For the first segment, we identified the Reddit users who posted in both subreddits about opioid, here called Opioids, and the subreddits about pregnancy and babies. And then we pulled their posts from Opioids subreddit. And then for the second segment, we pulled the data from the subreddit called Opioids, and then queried based on the pregnancy-related terms. So that's a combination of user history and key term searching. And then for the third segment, we extracted data from the subreddits about pregnancy and babies, and then we queried on opioids-related terms. And we combined the three segments data together to carry out the rest of the analysis. All right, go to the next slide, please. Okay, our next step is to run this sample data through a site-specific named entity recognition model in order to identify additional vocabularies that people might use to describe pregnancy, babies, and opioid. So, for example, we know pregnant is about pregnancy, and then the output from this model tells us that terms like labor, womb, maternity, these could all connect to pregnancy or baby. And another example here, as you can see from the right-hand side, for opioid, like codeine, quaaludes, opiates, these words could also be used by people to talk about, to describe opioid-related events in their social media posts. So these expanded vocabularies would allow us to do a more comprehensive data extraction, not from Reddit, but potentially from other social media data sources as well. All right, let's go to the next slide. Okay, because we did pretty comprehensive data extraction, inevitably there will be posts that are not relevant to our topic. So a very important step in our approach is to identify and remove irrelevant posts. So we built classification models to differentiate between relevant and irrelevant posts. So for that, we use a state-of-the-art NLP deep learning model called BERT. And after manually adding labels to some of our sample data. So BERT is based on transfer learning, and so it provides a pre-trained model, and we only need to fine-tune the model in order to solve our specific problem. And if it's time for development, requires less data and achieves better results. All right, go to the next slide, please. Okay, so our next few steps is to build classification models to put the posts into 4 different groups, including drug initial use, drug abuse, drug relapse, and posts about treatment. And then we also use machine learning models to help us identify the factors that are most important in classifying this data. And so in the process, we use IBM Watson services because they really help us speed up the analysis. So the first step here is that we annotate a subset of data into a list of custom entities to represent prospective factors related to opioid usage. So, for example, commodities, depression history, drug use. So we identify the words that are related to these identity types and then annotate them on the sample data. And then that will allow us to develop the model and extract these entities from remaining data and do classification next. So here, after annotating a small subset of our data, the Watson Knowledge Studio developed a machine learning model for us that would allow us to extract entities from remaining sample data. And then we uploaded the cleansed Redis dataset into Watson Discovery, and then extracted the entities that I just talked about using model from Watson Knowledge Studio, and also carried out scientific analysis on each of the posts. All right, next slide. Okay, and then our next step is to get the counts of these entities from each post, and then we built a machine learning model, and that help us to put the posts into the 4 different categories. All right, next slide. And our final step in the analysis is to summarize the sentiment analysis results for the posts that
Hi, can you hear me?
Yes.
Okay. So now I'm going to talk about the initial results. Next slide, please. All right, so this is a dashboard of our results. So due to time, we don't have time to really show you and play around with the dashboard itself. But just to give you an idea what it looks like, we have some graphs, some pie charts on the left-hand side that break out the category by those 4 categories that Ali described in an earlier slide, as well as the sentiment analysis and the pie chart on the bottom left. If you were to click on any of those categories in the pie chart, you would see the an example post data show up in the middle section. And on the right-hand side, it lists in the bar charts the most important entities when we looked at feature importance for the different categories. Next slide, please. So the first analysis we did was to identify a relevant post. So when a post comes in, we need a model to tell us, is this relevant or not? So we built a classification model using the BERT NLP technique that Ali described in a previous slide, and trained this model on a data set with 423 posts. So you can see the matrix in the middle that's looking at the predictive irrelevancy against the actual relevancy, and overall this model was performing with an accuracy of 73%. On the right-hand side, you can see some sample irrelevant posts. In these examples here, the word baby was used, but it doesn't reference an actual infant. So just to give you an idea on some of the posts that the model was looking at to try to categorize appropriately. Next slide, please. So after determining if a post is relevant or not, the next step is to categorize it into the 4 categories that Ali discussed. So you can see we have the number of posts broken out by the different categories: drug initiation, abuse, treatment, and drug relapse. And we used a random forest classification model that had an overall accuracy of 93% to look at the feature importance, and it ranked the following 6 entities as the most optimal for the model. Those included drug type, pregnancy month, comorbidities, past drug use, marital status, and pregnancy complications. So you can see that drug type was overwhelmingly the most important feature. Next slide, please. So we did a similar breakout for each of the 4 categories, where we built a model that then trained the posts within each category. So this one is for drug initiation with an overall accuracy of 98%, and the optimal number of factors in this case was determined to be 4. Next slide, please. Quite similar, same type of process for the drug abuse category. I won't spend for time purposes, I won't spend too much time on this slide either, but overall, the random forest model had an accuracy of 92%, and there were 7 optimal factors for this model. Next slide, please. And lastly, with drug relapse, 95% with optimal number of factors determined to be 3. Next slide. So next, we looked at the sentiment analysis across treatment types that Ali discussed and trying to determine if the post overall was positive, was it negative, or was it neutral. So you can see in the bar graphs that the overall sentiment was overwhelmingly negative, and particularly if post contained treatment that included any of the drugs listed in the last bullet, such as methadone, or where users were described as going cold turkey. So if the phrase cold turkey was used, those were both tended to be overwhelmingly negative. We also wanted to point out that any post described as neutral either contained a question or there was limited data, meaning that the post itself only contained a title and there was no data in the body of the post. And due to limited data, it tended to be classified as neutral in those cases. And so next we get into future steps. Next slide, please. So there's a bunch of different directions where we can go with this project. First and foremost, increasing the amount of the initial sample data through more comprehensive Reddit queries. We only looked at specific subreddits, for example, only one opiates-related subreddit. Additionally, we were only looking at the post data itself, and in future iterations, reading and comments data may be particularly useful, especially if the post itself was determined to be relevant. Secondly, expanding our vocabulary list that Ali talked about on a previous slide to overall increase the data that we get and have a more robust sample size. Evaluating other social media networks for their feasibility. So we only looked at Reddit, but there's other social media networks, Facebook, Instagram, Twitter, etc., that may also lead to additional data points that we can capture. We provided a high level of the modeling techniques that were used, but further refining those models and looking at additional modeling techniques to achieve models with an overall higher accuracy. Next, conducting trend analysis, such as geographic distribution and temporal distribution. So with some social media networks, you may be able to identify a location, and if we're able to pull in that information and understand if more posts are coming from a particular area, that may result in targeted outreach or other similar initiatives. And lastly, integrating or comparing data with other data sources. So if we pull in data from multiple networks and pull that data to achieve a more integrated view, that may result in us uncovering insights that may not show up if we're just looking at the distinct data sources. Next slide. All right, and now I'll hand it over to Jesse.
Okay, thanks, Sarah. Now I'm going to touch briefly on some opportunities that could be possible based on our work. Next slide, please. Data has the most impact when it can be integrated with other platforms, and by integrating our platform with others in the federal space, we can make each system's data even more powerful than they would be on their own. So one example would be combining information from agencies in HHS, so like FDA, CDC, CMS, and with local governments and health insurance providers to identify potentially chronic opioid users. And this could provide opportunities for support to overcome their addiction. And of course, this also means various databases and tools would have to be able to talk to each other, which could create unique challenges in and of itself. Next slide, please. So Cedar at FCA is taking steps to mitigate these unique challenges by creating the Cedar Opioid Data Warehouse. As you may know, this warehouse was recently created by the Controlled Substances Program within the Cedar Office of the Center Director. It's a large-scale data warehouse intended to integrate internal and external data sources and provides analytical capabilities for that data. So leveraging the data in this warehouse, our team could aid CSP in expanding and integrating sources, identifying trends in vulnerable populations, assessing the population's needs, and anticipating new developments in the opioid crisis. Next slide, please. And finally, by incorporating NLP into any platform while looking across multiple social media platforms, that really gives an opportunity to for the users to basically do nearly real-time monitoring. So this real-time monitoring then allows teams to perform analyses regularly, and this could help provide local governments and organizations dedicated to identifying, educating, and preventing further opioid misuse additional information, and this can inform resource allocation in areas most affected by the crisis.